Second online tutorial for NucliTrack. In this tutorial, I'm going to show you how to load data into NucliTrack using a text or CSV file, and I'm also going to show you how to export selected tracks with data that you're interested in. So to start with, I've downloaded this RPE example data from the NucliTrack website. Within this folder, there's both imaging data in this folder RPE1 here, as well as labelled images in this folder labels here. Now each labelled image is basically a sort of a segmented image where each segment has a unique label. Now these labels come from NucliTrack using segmentation that I performed earlier, but these could also come from other software such as Cell Profiler. So there's lots of other better segmentation software out there. Just have a look and find one which exports it into single plain TIFFs like this. Finally in this folder, there's also this file list.csv file. Now if I load this up with text edit, we can have a look at the structure of it. So on each line, there's both a file name, here specifying the image file in the folder RP1, as well as this number 1, and they're separated by a comma. This number 1 indicates channel 1, so because our image series is multi-channel. Again, we have each new row has a new time point on it, and these numbers now, because of this is a text file, these numbers don't have to be zero padded, but this is the way that our microscope exports them. We scroll down, there's 380 time points in this, or 385 time points in this series, and then it changes to channel 2 here. It's necessary that each channel is sort of sequential, so we have channel 1, then 2, then 3. So keeping on scrolling down, we reach channel 3 here, and then we get to channel 0. Now channel 0 indicates our label data. So we can see here this folder labels, then followed by the labelled images. There needs to be exactly the same number of labelled images as there are in the types of images in the time series, and each image needs to be the same dimensions. And these are indicated with this 0 here. Okay. Now what you also notice is there's a black backslash used here. We're on a Mac here, or a Unix system, so we just need to change this into a /, and we can do this quite quickly using find and replace. So here I've just changed them all to / so it'll work now, and I'm going to save this right now. So save this, close it down, and now we've got this folder all ready to be loaded into NucliTrack. So I'm now going to go to my applications and launch NucliTrack. So I'm going to navigate to where this data is saved. RPE example, and again I'm going to create HDF5 files to store our tracking data and the parameters we choose for tracking. So I'm going to select this time, rather than load from file names, I'm going to select load from text. I'm then going to double click file list.csv. So it'll take a little bit of time now because we've got 385 images, 3 channels and label data to import. This is now completed, and we can view these labelled images in this view segment. See how we jumped the segment and segment movie steps previously that we had to perform. So we can now extract features. It takes a little bit longer as of course there's a lot more nuclei and 385 images. It's getting slower towards the end of this sort of image series, so there's even more nuclei per image which need features extracting from. But nearly done now, and all done. So we can now have, as before, we need to sort of select training classes for the probabilistic tracking to work. So I'm just jumping around selecting a whole bunch of these nuclei. Lots for class 1 because the majority of nuclei are just single segmented nuclei. I'm now going to select mitotic exit, so I know these 2 cells have just exited from mitosis. And then we can see the mitosis happening here. So I'm going to select that as a mitotic cell. There's another case here where the cell is undergoing mitosis. Skip one frame ahead. and then the mitotic exit happens here. There you go, mitotic exit is happening here. Now we don't need to be too precise on this because it generally gets it pretty right. In fact, the one that I just highlighted there was a mitotic cell. Let me just swap that over to mitotic cell. A few more examples of single cells, and I think we'll then be ready to... Yep, I think we're good here, so I'm going to save this training as before. Now, there's a lot of nuclei, and it's a long time series, so I'm going to bring the search distance right down to about 30 here, and also reduce the gap. So this is going to make sort of tracking proceed a bit faster. In fact, I might just load just a little bit below 30. And I think these parameters are now quite nice for tracking. So I'm going to classify the cells and select track. We're going to see how many cells NucliTrack's going to track this time. From memory on this video, it's around about 400. Okay, so it's now going through what are called optimization sweeps. And here, basically, NucliTrack removes the track that it originally found, then tries to reinsert this track. It'll either go back to the original track if no better track can be found. Otherwise, it will go through and find a better track and basically call this the best track. It continues to do this several times over, or in 2 sweeps. And it's basically jiggles all the tracks around until they've really found, sort of an optimum configuration. You could carry on doing this until sort of certain stopping criteria are reached, but I've generally found that 2 iterations of this sort of optimization is more than enough to get some pretty good tracking results out. So tracking's finished, and compared to the several hundred segments we had from the last video or last tutorial, this time we've got 14,700 segments that have been tracked through. So let's just have a look at the results of this. So there we go, we've got all of our tracked nuclei here. What you'll also notice here, compared to the last tutorial, we've got a little black bar indicating where we are in the video, and we've also got a clear event button here. And these are 2 sort of suggestions that one of the postdocs in our lab had, so I integrated these. So this, if you guys have any suggestions as well on how to improve NucliTrack, I'd love to hear them, and I'll try and implement them as soon as possible. So let's get going with this sort of track amending and inspection now. This is the P21 channel we're looking at now, and basically P21 increases over the duration of this imaging sequence. Let's change channel to channel 3, which is the PCNA channel that was segmented on. And you can see this sort of remains rather constant. Now then, so I'm going to scroll back to the beginning to somewhere in the video and select a nuclei to see what's going on. So here we're basically looking at this feature here. In green is P21, and in red we've got the area. I'm just going to, number 5 this is P21 here in green. I'm going to set that as the first feature. I'm going to go to 11, which is PCNA intensity. And finally, I'm going to have 13, which is PCNA standard deviation. And this is a measure of when cells are in S phase. So right now, this nuclei here is we're looking at this blue spike in the PCNA foci intensity measure. And this cell is going through S phase, and here it basically exits S phase when these foci disappear. Now, NucliTrack has made several mistakes in this track. You can see these as the large jumps in intensity. We could possibly use the intensity itself to improve tracking, but we prefer not to, as this might lead to sort of artifacts in our data and results. As it might be basically, we might miss mistakes, whereas really we just want to see the mistakes and double check that they're correct. So here perhaps another mistake. So here the cells undergoing mitosis, basically before another mistake's made here. I'm just going to correct this. And the second mistake here. And this cell nuclei disappears. So throughout NucliTrack, we're basically, what we've got here is we've got a cell that's basically exiting S phase, coming out with this peak in sort of the foci measure, undergoing mitosis here, and then P21 in red here starts to shoot up again. I'm just going to choose a different cell to try and get one which is perhaps tracked a bit longer. Okay, so this track's very nice here. This, we've got a cell exiting S phase here. We can again see by the blue peak. P21 switches on again. Please read our recent paper that myself and Alexis published on P21 levels, and this you can understand what's going on exactly here. But yeah, so this cell is basically exiting S phase here. It'll undergo mitosis shortly, and then this appears to have correctly tracked the cell nuclei after mitotic division, as we don't see any sudden jumps in the intensity levels. I think there's a mistake here, so I'm just going to go, in fact there might even be a mistake here, I think, so I'm just going to go back and correct this. Pressing X to swap tracks. Okay, so let's say we're interested in what happens to cells after they exit S phase. So let's say this is now an interesting track. We're looking for about 100 frames after they exit S phase to see whether they arrest with high P21 levels or continue to cycle. So here, the cell is just exiting S phase. You can see the nuclei here, this peak here, and it's just suddenly going to disappear. There we go, at the end of S phase. So what I'm going to do here is add what's called an event flag. So I'm going to use the hotkey I, or by pressing event 1, and then click on the frame that we're on at the moment. This yellow bar appears, indicating that event has now appeared. I'm also interested in this track because it's got the data we're interested in. I'm just going to flag up the mitosis here. NucliTrack may or may not should record this mitosis automatically because of this red dot here, but just to be on the safe side, I'm also going to record it using event flag 2. Okay, so I'm going to put event flag 2 where there's mitosis happening, and that's just that's to be absolutely certain that I've sort of quality controlled this and checked mitosis is happening. I'm happy with this track, so I'm now going to store it before searching for a second track, which also indicates the behaviour of P21 after mitosis. And so here's another track where we're basically, this track again looks very nice. We've got the cell entering S phase here, where it switches off P21, so we can follow it here quite nicely. Oh, it has undergone a mistake there. So let's just correct that. Let's take this cell here. I can be a little bit rough with how I handle data because we're just interested in the overall trend that's happening. Again, so there we go, the cell's entering S phase quite nicely here. P21 levels drop off, PCNA foci are increasing. So let's see if we can track the nuclei for any amount of time previously. It looks like so it comes onto the field of view about there. So this is a nice track here, comes onto the field of view, track it over S phase, then it's exiting mitosis here, and see a mitotic event, and then it tracks effectively for the rest of the frame. Same as before, I'm now going to select I for this frame. I'm going to select I and indicate where it exits S phase, and 0 to indicate where it undergoes mitosis. I can see this sudden drop here. This is where mitosis is. Perfect. This is another track we're happy in, so I'm going to go ahead and select store track. This track's stored now. We can actually see both of our stored tracks using these two little black dots. So I'm now happy with these two tracks. I want to use them for future graphing. So what I'm going to do is, rather than exporting all of the tracks to CSV files, I'm going to export selected tracks to CSV files. So I click that. We'll now see filelist.csv appears in this folder. Or sorry, example, not file list, we've looked at that already. Example data selection.csv. If I open that with numbers, we can now see these two track IDs, 125 and 158, have now been exported as CSV in the CSV file. And in fact, what I can do is, if I go all the way to CH3 channel 3, channel 1, which is P21, and look at channel 1 intensity, the channel 1 mean intensity. Let's just do this for a single. I can now just do a quick graph to show you that this has in fact correctly exported. So I highlight all of this data up to the end of this track, 125. I can now insert a chart. Let's put a line chart in. And you can see this chart here now roughly corresponds to the data we had back in NucliTrack. So with that, I've now shown you how to sort of load in more advanced sort of multi-channel data using a text file. There's also a way to do this using the auto file loader. It's just takes a bit longer. And then also this now, and how to export single tracking data, which allows you then to analyse it for further analysis. So with that, thank you for listening, and please send any questions or suggestions you have for NucliTrack our way. Thank you very much then. Goodbye.